Okay, so geometric probability. The probability of a measurement compared to another measurement. The larger the measurement, the larger the probability. In this case, we're going to do the probability of landing on this red circle. The shaded area will be that red circle. So probability is always want over total. So in this case, it's the area of what we want over the total area. So we want that circle, and the total is going to be that outside rectangle. All right, so to find the area of the circle, we need pi r squared. So we need to know the radius. So if we look at our circle from top to bottom, we realize it fills the rectangle. So if the rectangle has a height of 10, then our circle has a radius of 5. So this is going to be pi times 5 squared. And area for a rectangle would be base times height. So that's going to be 21 times 10, which is 210. And now we just have to figure out what pi times 5 squared is, or pi times 25. Okay, pi times 25 is 78.5398, so 540. Personally, I don't like a fraction that has a decimal in it, so I'm going to divide 78.540 divided by 210 and give a decimal overall, 0.374. So the probability of landing on the shaded red circle is 0.374, or 37.4%. Okay, so let's try this one. Again, the probability of landing on the shaded space, which is that triangle. So probability is want over total, which in this case is shaded over total. And the shaded is a triangle, so 1/2 times base times height. So 1/2 times 5 times 7, which is 35 divided by 2, so 17.5, over total. Total is that rectangle on the outside, so base times height. The entire distance for the base is 8 plus 5, so 13, times the height is 7, so 13 times 7, which is 91, is our probability. Again, I don't like having a decimal as part of my fraction, so I'm going to divide that and say that the probability is 0.192, or 19.2%. Okay, level 2. In this case, we're going to find that shaded probability, the red probability, but it's the leftover. It's the missing space. It's what's left over when we have our rectangle and we subtract our circle from it. That's what we want. And then total is that rectangle. All right, so the rectangle probability, it's going to be 16 times 14. So 224. The circle, which is white, needs to be removed. So that's going to be pi times radius squared. So pi times 5 squared, which is 78.540. And so if we subtract those two, then we will have the shaded area, which is what we want. The total was the rectangle, so the total was the 224. So want, shaded, is 145.46 over total 224. Or if you divide that, 0.649. So about 65% of the space is red outside of that white circle. So that's your probability of landing in the red space. So sometimes we get our level 2 probabilities by subtracting. Sometimes it's by adding multiple probabilities together. So let's check out the final example. Okay, so here's another level 2. And this time, if we're finding the probability of landing on that red circle, what we want is actually one circle multiplied by 2. So if we can do pi r squared, then we can just multiply that by 2, and we'll have our wanted probability. So we will have 2 times pi times 2 squared. Whoops. That was supposed to be a 2. Okay. So, all right, so that's going to be 2 times 12.566. So that's going to be 25 over, or no, 25.133, or 132, since we don't have the rest of the decimal there. All right, so way back here, we had to figure out what total was. Now, total was just that rectangle, so base times height, which was 10 times 8, or 80. So our probability of landing on the shaded area, either of those two circles, is 25.132 over 80. If you wish to have that as a decimal instead of a fraction with the decimal in it, because it bothers you like it bothers me, then we would divide that, and that would be 0.314. So about 31% for the probability.